Welcome to today's webcast. This call is being recorded. And now, to begin our program, I'd like to introduce Chris Flack.
Hey, thank you so much, Jessica, and welcome everybody in our audience to today's webcast, Software-Defined Storage Architecture, Optimizing Business Value and Minimizing Risk in Microsoft VMware Storage Strategies, sponsored by StarWind Software. I'm Chris Flack with Virtualization Review, and I'm here to briefly introduce today's webcast and go over a couple instructions with the audience. So thank you all for joining, and we appreciate you taking time out of your busy day to do so. Just a quick reminder that we will have a Q&A session at the end of today's program. However, we do encourage you at any time during today's presentation to enter your question via the Ask a Question box appearing on the left-hand side of your console. And hopefully, if time permits, we'll get to everybody's questions and get out some answers. If we don't get to all the questions, don't worry. We'll have somebody from StarWind follow up with you after the webcast is over. Also, today's webcast is being recorded and archived for future viewing and listening purposes, and we'll send you a link to the email you registered with within 24 to 48 hours after today's webcast. Please feel free to share that link with coworkers, colleagues, friends, anybody who may be interested on today's topic. Also, we are giving away a couple free copies of Symantec's Virtual SAN trial, so keep an eye out for your name to be announced later in the webcast. We'll pick two random winners at the end of the webcast today, so keep tuned to the end of the webcast and see if your name is called for the giveaway. But joining us for today's webcast, we have two really great presenters. First up today, you're going to hear from Jon Toigo. Jon is John's a 38-year veteran of IT. Has worked as both an operative within corporate information systems departments and as a senior consultant with 2 international systems integrators. He's developed business continuity plans for more than 100 companies and has authored 17 books, including 4 on disaster recovery planning. He's written thousands of articles and columns for the Computer Trade Press and has spoken at countless industry events, trade shows, workshops, and webcasts just like this one. And with that, I'd like to introduce Jon so he can get started with today's webcast. So, Jon, why don't you get the floor started and get the show started?
Thank you, Chris, and thank all of you for attending today's webinar. Again, the topic is software-defined storage architecture, so if you came here for something else, you probably are missing the webinar you intended to see. But I'm delighted to see how many of you have shown up on this very important topic. This is actually the first of a series of sessions that we've got planned that will dig deep into the nuances of the various strategies that have been put forward by various vendors, led, of course, by industry leaders Microsoft and VMware in the area of software-defined storage architecture. My goal here is basically to get us off on the right foot by clarifying exactly what software-defined storage architecture is, or at least what it should be, and what interpretations are being made of that by leading hypervisor vendors. Now, companies like Microsoft and VMware have been busily productizing their software, their software-defined storage solutions, mainly to work with their own server virtualization software stacks, creating sort of a one-stop shop approach for server, network, and storage virtualization. Now, this presentation doesn't seek to evangelize any single vendor's products, but only to provide some context for sorting out the marketecture from the architecture when it comes to SDS. Now, I hope that you're going to find this session useful and that you'll participate actively in our discussion later on in the event, as well as attending the 3 subsequent presentations we'll be doing over the next few weeks. So without further ado, let's get the show on the road here. All right. Now, you probably would have had to have been thoroughly distracted by other things for about the past year and a half to have missed all the commotion around software-defined storage architecture. Surveys suggest that the concept's been gaining mind share, especially in response to the storage challenges that are created in part by server virtualization itself. It seems like every server hypervisor out there has its own take on what software-defined storage is and why you need to dismantle your quote-unquote legacy storage in favor of this newer storage topology. Now, unfortunately, their evangelism of software-defined storage has seen a lot of marketecture get mixed up with the architecture, so much so that confusion is eclipsing clarity in many of the discussions that I read in the trade press of server-side or hyper-converged or whatever they're calling it this week, and also in analyst reports and in what I hear on stage presentations or even in webinars like these. There isn't a single common definition of the term. which makes it sound more and more like an airy concept than like an actual architecture. And worse yet, some vendor definitions are designed more to exclude their competitors' wares than to create any kind of real definition that's meaningful from a computer science perspective. So I'm a big believer in clarity, as some of you on the call probably know, and I think the best architectural decisions are going to be made when we have all the facts. Now, if you agree and you're seeking clarity about software-defined storage architecture, then you come to the right place. I'm delighted, by the way, to have sponsoring this event, StarWind Software, which I think has done a real yeoman's job of trying to produce a hypervisor agnostic and hardware agnostic solution to this whole software-defined storage thing. I'm looking forward to chatting with their representative a little later in this call. So, again, my goal here is not to evangelize software-defined storage architecture per se, but only to try to help us all understand what it means and how it works. And I hope that this will better equip all of us to have good discussions with our vendors and to determine what the available alternatives are for software-defined storage that might be the best ones for our environment. Okay, now, to begin talking about server-side or virtual SAN storage architecture, this software-defined stuff, it helps to start with a brief review of certain other storage terminology that often creeps into the discussion. For the last decade or so, we've been hearing that storage comes in three basic flavors. You have direct attached storage, or DAS, you have storage area networks, or SANs, and you have network attached storage, or NAS. That all sounds very complicated, but DAS basically was a scenario in which internal server storage components, such as disk drives inside the server case, as well as external storage arrays consisting of a storage controller and trays of disk drives that are encased in their own cabinet, would be attached to the bus of the main board, the server motherboard, using a host bus adapter that's installed on the server and, of course, a length of cable that makes that connection. So you directly attach the storage to the box. SANs were also connected to servers via an extension of the server bus backplane using a host bus adapter and some cables. Virtually all devices spoke the standardized language of SCSI, the Small Computer Systems Interface, which has been worked into a set of serialized protocols, serial SCSI protocols, if you will, that include fiber channel, iSCSI, which is SCSI over Internet Protocol, and of course most recently Serial Attached SCSI, or SAS. Now, NAS, on the other hand, was actually a file server reimagined as an appliance. With NAS, the disk drives are still in a direct attached mode to a thin server that's optimized for file storage and file sharing. And the resulting file server appliance is accessed via a network file system protocol, such as SMB 3.0 from Microsoft, or the network file system, NFS, running over a TCP/IP network. Now, despite the varied terminology, the truth is that all storage is direct attached storage. I know we've heard three different flavors, but it's all direct attached. The fact is a SAN is definitely direct attached storage. There's simply a switch stuck in the cable to make and break those direct attachments at high speed, which kind of looks a little bit like a network. Still, defining fiber channel SANs as networks really is problematic for the people who believe that they know what networks are, and they don't think that fiber channel SANs fit that model. They're properly regarded as fabrics, not as networks. Now, NAS, as I said before, is actually a direct attached storage configuration as well. It's a standalone server with trays of drives directly attached to the server, and then you put a cabinet around the whole thing, and you call it an appliance, and you access it via SMB or NFS or whatever. So at the end of the day, you're looking at all direct attached storage. Now, the other distinction that the industry likes to make is they used to call DAS and SAN block storage. It was used to store block data. That is the output of databases and other application products that primarily stored their data just as locational bit patterns, if you will. Other applications didn't use this kind of structure. They used files. They produced their data in the form of blocks that were organized under a file structure, if you will. So at the end of the day, really all data is block data. And the format of that data, whether it's file-based or it's block-based, has a lot to do with what the application does when it reads it, and with the structure of the way that it's placed onto the disk or onto the storage device. Okay, so the key point here is that all storage is block storage, and all storage is direct attached storage, whether you call it DAS, SAN, or NAS. And perhaps the one valid distinction between the latest software-defined storage, called a virtual SAN, is that it can be deployed as a set of cheap, direct attached storage that operates in a holistic way with or without a switch. So some SDS vendors would disagree, but vendors like StarWind have demonstrated that their SDS SAN, their virtual SAN, doesn't require a switch, but still delivers a lot of the value that you've come to expect from a SAN implementation. All right, now that's kind of a short course in storage at the rudimentary terminology level. Let's look a little bit further up the stack here at how we actually deploy storage today. If you turn to my little history of storage, I've written a few books on this, so I'm not starting completely from scratch. Storage has come a long way from being a simple block data repository or a disk drive in a machine cabinet. Today's storage represents a combination of software and hardware components and protocols arranged into an intelligent system. In 1987, for example, we heard about RAID, redundant array of independent disks. Actually, it was inexpensive disks, but it was never all that inexpensive, so they changed it to independent disks, where these were various techniques of combining a bunch of disk drives together so they could represent themselves as a single disk drive or volume. There are many kinds of RAID. 5 techniques were standards-based in the original white paper, but there have been a number of other techniques that were created as proprietary value-add technologies by various storage array vendors. Now, RAID could run as software on the server, or it could be implemented on the array controller, which is the brain of the contemporary storage array. Today's array controllers, in fact, are typically PC or server motherboards that are running a commodity operating system like Linux or Windows, and they host the RAID software and maybe some other value-add features the vendors elected to add to his kit, like thin provisioning or deduplication or mirroring or whatever, that basically can be used to increase the price of the storage array, exponentially in many cases. The array controller, and there's usually only one controller, is quite often not a redundant component, which seems to be kind of counterintuitive if you want high availability in your infrastructure. However, the components that are often made redundant are what we would call the interconnect components. These would include the cables between the controller down to its trays of disk drives, the power supplies on those drives, the fans on those drives. Those are, in high-end systems, made redundant because those are moving parts in many cases, or parts that experience a lot of wear and tear, like the disk drives themselves. So just as you use RAID to try to protect against a drive failure, you do redundancy on those other components in order to try to protect against a failure of one of those components. And we also find along the way there's been a lot of experimentation using different kinds of controller configurations, dual-ported controllers, etc., that would enable us to share a storage array a little better or to create storage clusters. Now, some of that technology is being explored once again in connection with software-defined storage. So I only throw that out there at the moment. We'll get back to it in a second. Last thing I want to point out is on the left-hand side of this slide, you see that there's a stack of software that the data has to travel to. And we're talking about in a large shop 4 trillion bits moving across this transport and down this protocol stack in order to write data to whatever the destination device is. And all of these things have to work synchronously or in proper conjunction with each other in order for the data to reach its location. That's 4 trillion miracles a day when you think about it. Now, that includes disk drivers that are loaded in your operating system. It includes the SCSI protocol that you're using, the adapters and their drivers, the host bus adapters, maybe some additional software that things are going through on their way down, value-add software added by the vendor. Now, if any of these software components are incompatible, or if they're in disarray or disrepair, you can't access any data on the storage array from the impaired server. So that's kind of important because now we're beginning to see a lot of research appear in the market that looks at the causes of storage-related downtime, which has become an issue for a lot of companies that have always-on applications, can't afford even the smallest amount of downtime anymore. It used to be you could go for 4 to 8 hours without a mission-critical application. Now you have to have that application configured in an always-on state. That's not all of your applications, but certainly some of the key ones. Now, the good news is that we got a bunch of longitudinal data not long ago, and the University of Chicago did a yeoman's job of breaking that down, and they found that in high-end systems and in mid-range systems that a disk failure is your most typical cause of downtime. And we got to get worried about that because we're finding out that disk failures occur 500 to 1,500 times more frequently than we used to believe they did. And that also we're confronting issues like bit error rates on disk that are non-recoverable errors on the face of the disk that if you write a file to, you'll never be able to retrieve that file, or you will retrieve it and it will be broken. And if it happens across a parity stripe or something, it can take out a whole RAID set. So you can have a really bad day if you have disk problems. And then the red section on all these pie charts refers to that interconnect I was talking about, the cabling and the fans and the power supplies and those devices which make the physical connection down to the trace of disk drives. Something goes wrong there, and again, you're going to have downtime. Now, interestingly, in the low-end systems, which are on the left-hand side, that's actually the leading cause. Interconnect failures are the leading cause of downtime in the systems that support remote offices and small businesses and that sort of thing, mainly because they don't buy those with redundancy. A low-end system oftentimes doesn't have dual power supplies or whatever, so you kind of expect that to notch up a bit. And all of them are conflicted by maybe a double-digit, 9% to maybe 12% of downtime that's the result of problems in that software protocol stack. Now, this is really important stuff. We never had this information before. We just always kind of assumed that, the complexity of our storage arrays was resulting in increased downtime. Now we've got actual evidence about what the causes are. And today, that's part of the reason why we look at, the possibilities that are involved in this server-side storage configuration, this redundant high availability configuration that's called virtual SANs. And also sometimes called hyper-converged or whatever. We're going to replicate the data all over heck and half of Georgia among multiple machines in order to ensure that if one of them has a problem, the workload can be reinstantiated on one of the other servers. In fact, server virtualization is really the key driver here because, as mentioned previously, it's introduced new pressures onto an already complicated storage infrastructure. With the advent of server consolidation using server hypervisors and storage, the storage I/O patterns themselves have changed. So instead of a lot of 1U rack mount servers, each running its own operating system and business application, in most cases with one network interface card or one host bus adapter to connect a DAS or a SAN storage, instead we've started to see more powerful servers deployed running multi-core processors with hypervisor software being loaded in order to host multiple virtual machines on a single frame. Now today, we have between 3-to-1 and 12-to-1 virtual machine to physical host ratios. So we're running the equivalent of 12 1U rack servers running each their own application on an individual server in a virtual environment. In the process, we needed to equip each server with the capability to host the most demanding virtual machine workload that it might be called upon to host. So that big customer service database that requires multiple network links and a lot of interconnect capacity. And we found that every server acted as a host for virtual machines needed somewhere between 7 and 16 I/O connections to support hypervisor features like virtual machine failover and load balancing wherever that was something that we were trying to implement. Now, the effect is known as an I/O blender by some. Lots of virtual machines hammering a storage system at the same time at random with small block writes. Flash handles that kind of traffic somewhat more efficiently than disk, but it actually kills the parity stripe in a lot of rating protocols that are out there. Software-defined storage developers are trying to address this, the situation of I/O Blender in a lot of different ways that we'll be discussing in future presentations. For now, the virtualization advocates are simply observing that storage has to change in order to accommodate this new kind of I/O pattern that we're seeing. And also along the way, it has to become less complex, and we're in order to realize all the benefits that we're supposed to be realizing from virtualization. Okay, so that's kind of a long way to get to a couple of simple points. One is moving outside the box. Obviously, the whole infrastructure gets a little complicated. Today, we've got heterogeneous equipment from different vendors who don't necessarily work and play well together. We have complex switching for fiber channel fabrics and that sort of thing, where the routes are predefined through switch ports and through various worldwide naming schemes that you have to become sort of an expert in order to manage. And of course, we have I can't hardly read my own writing here. We have isolated value-add controller functionality. Every box has its own onboard controller, and that becomes a point of management that we're doing kind of a bad job of managing generally when it comes to storage infrastructure. And then, of course, you've got specialty device drivers on every server. These were a lot of contributors to the issues of why storage was so expensive and why it was so complex and why it was prone to failures. Not to mention the fact that it created a singular issue for the virtual environment. You know, we were all going to invest in virtualization in part because we could move workload from one machine to another machine, and we could just slide it over there. Maybe that was to eliminate planned downtime. We could basically take the workload off of a machine that needed maintenance and move it and reinstantiate it somewhere else. That was a wonderful world of wonderfulness as an idea, but the problem was that with legacy storage, quite often you had to go into the application and modify its route back to its data if it's set up on another machine. Just simply, you know, the location of the workload had changed, so the routing instructions on how to get to the data needed to be adapted too. And that would slow down the process at a time when we're all shooting for greater resiliency and greater agility. You hear those terms all the time. Now, that prompted a little bit of creative engineering. You know, the response of some of the hypervisor vendors was to recommend that SANs be broken up in favor of direct attachment of arrays to each server. Okay, now that's not to sound retro, but vendors kind of referred to this as server-side storage topologies or software-defined storage, or vSAN early on. By replicating data, virtual machine disk files in particular, between each of these DAS arrays, workload could fail over to any physical host, and it would find its data on the same local drive that it was accessing in its original position. You know, that was the idea behind all this mirroring that was going to go on. And there was some initial debate about how data mirroring would be handled. You know, the term software-defined storage suggested that this hypervisor software on the server would control data replication. But given the generally poor performance that customers were experiencing from early server hypervisors in handling storage I/O, some vendors pressed the idea of offloading all these mirroring operations to intelligent array controllers. You may have heard of VMware's VAI, which were initially 9 non-standard unapproved SCSI commands that were simply inserted into the SCSI command language without asking the ANSI T10 committee, which controls SCSI, whether or not they could get legitimacy for those things. And as long as the array controller understood these VAI commands, they could do a bulk offload, and instead of the hypervisor controlling that mirroring process, they could just let the controller do it, the value-add software on the array controller. That was an interesting approach. It didn't really alleviate as much of a problem as they thought, and good news is that eventually they did go to the ANSI T10 committee and get some of those commands approved, so they became extensions of our command set. Today, the method that's used to control replication is all over the place. Some vendors are supporting VAI-like handoff of mirroring to array controllers, and others, including VMware itself with its current virtual SAN approach, doesn't support VAI at all. Now, so there are a lot of different ways to skin this particular cat, and I won't go into them here. Frankly, we'll get into them in later sessions, and they do become very important to realizing the promise of virtualization, and whether it's a clustering solution or it's a failover solution, you really do need to have a good, solid mirroring scheme behind it. All right, now at the end of the day, and this concludes my little short history, if you will, the question that storage architects are debating is really kind of an interesting one to me. Is this server-side storage thing actually advancing the narrative of storage architecture? We thought we were moving from isolated islands of storage when we had direct attached storage back in the 90s into a more shared storage configuration when we deployed SANs, and then ultimately, hopefully, moving towards some sort of a true SAN evolution. However, now we're being told to go back to directly attaching the storage back to the servers again. And it kind of looks like we're de-evolving. Now, this will probably spawn a lot of debate whether that's the case or not. I know that StarWind is pretty passionate about the fact that they've just simply come up with a different way to configure storage, and it's still extremely shareable and certainly supports a broad range of clustering and a lot of access by different servers. At the end of the day, we'll leave that debate up for the question and answer session later on. Evolutionary or not, we are all intrigued by the idea of doing server clustering or storage clustering with back-end synchronous replication as a means to maintain highly available workload processing while enabling our infrastructure to scale much less expensively than it would if we had to deploy a fiber channel fabric and scale that. So there is a lot of interest here. Now, one thing that potential adopters are discovering, however, is that there are very different implementations of this software-defined storage by VMware and Microsoft, who are the two dominant vendors currently in the x86 server hypervisor market. And it's creating some concerns. I mean, VMware has recently taken to calling its architecture Virtual SAN, replacing an earlier vSAN moniker that harkened back to technology from Cisco Systems. I think they were probably stepping on their patent and had to do with segregating fiber channel SAN fabrics. Microsoft instead refers to its solution as cluster storage spaces, building on a theme that originated in Windows 8 and Microsoft Server 2012 called storage spaces, but adapted to the evolving high availability clustering vision that's become a fixture in current server hypervisor marketing. Now, these are both trademark names and belong to their owners just for the purposes of legal disclosure. I certainly am not an advocate of either one. What I will do is very quickly walk through the value case that's being advanced by VMware and then the one being advanced by Microsoft. This is based on research, based on investigations of what early adopters are saying, and I vouch for it only in those terms. It's what's available from public sources. Now, VMware offers a video on their website to explain the value case for its virtual SAN. You can watch it whenever you feel like it. Summarizing their pitch, however, they say that conventional storage systems are being overwhelmed by demanding workload, that needed is a way to simplify storage, to abstract disks and flash drives, and to enable them to be pooled and delivered as a software-based service. Virtual SAN from VMware is supposed to provide such simplicity without sacrificing performance. Now, current storage policies to meet workload service level requirements, and those are becoming in vogue. We want to profile the workload. We want to be able to come up with just the right kind of storage to support that workload. And we want to be able to expand that capacity or performance over time just to add more nodes to the cluster or disk to a node. And this all sounds like a wonderful concept. The architecture uses local storage and direct attached JBOD arrays of SAS or SATA disk, minimizing the I/O path and delivering more performance than most virtual appliances could, according to VMware. And plus, the architecture uses flash storage as cache for write buffering and logging. Now, in addition to the technical advantages, there's supposed to be additional cost savings that accrue to the VMware model for virtual SAN. On the OpEx side, you no longer need staff who have any kind of storage skills. They don't need to know storage from Shinola, since there are no LUNs or RAID levels to administer in this solution. All disk and SSDs are abstracted into resource pools that are readily assigned to workloads based on service level requirements, and the vendor says that provisioning processes are streamlined, that you can basically issue storage to workload very rapidly. Now, from a CapEx perspective, all the hardware used to create each node is supposed to be commodity stuff. So, scaling up only requires the purchase of more disk. This all sounds like a wonderful world of wonderfulness. It's going to drive down the cost of storage over time. Now, given the lack of proprietary gear, VMware claims that its solution is going to be 50 to 70% less expensive in terms of total cost of ownership than traditional NAS or SAN. That sounds like a pretty good idea, and then you look at their list of basic components, and the basic components of a vSAN cluster are supposed to be a minimum of 3 nodes, 3 servers, vSphere servers, that create a data store. Each node must have both solid-state drives and a minimum of 5 1-terabyte SAS hard disks. And then there's a 10 gigabit Ethernet connection that's recommended for interconnecting data stores to the vSphere nodes. A 1 gigabit Ethernet will do, but it's not going to deliver any kind of performance. So the setup is supposed to be fairly simple, and then when you're doing your wizards to actually configure the storage to your applications, you simply check a box on the setting page in the vSphere cluster and work through a short list of criteria that are there, basically clicking off check boxes and entering a few values. It's supposed to be so simple this guy on the right can do it. Okay, vSAN is tightly integrated with the ESXi kernel, and that means that the storage is provided directly through the hypervisor and not through a separate virtual machine, which is the way you do it if you're using a product like Nutanix. It also means that vSANs require no additional software installation beyond vSphere itself, and that is the ESXi hypervisor and the VMware vCenter server. I'm not going to dwell on this because we will be digging into the particulars, but the really important thing here is that when you're setting this all up, there are just a few little configuration parameters you have to concern yourself with, numbers of failures to tolerate, how many drives you can lose before you have to quiesce that particular node and add drives to it, number of disk drives per object, and the idea there is that you get better performance the more stripes you have or the wider the stripe. Flash read caching and how much you want to reserve for that. That again goes to performance issues. Object space reservation, force provision, you can read this on their website and get all the particulars. But the point is that once you are at least basically familiar with these concepts, supposedly you just set some parameters and boom, you're loaded for bear. You're in business all of a sudden. Now, what have the results been? I mean, what are the users, the early adopters of this technology, because it is still kind of a beta technology, what have they decided is good or bad about it? Well, the response generally has been positive among those who are already using vSphere and ESX and who are sort of loyal fanboys to VMware. But the deployment has not been without its pains and struggles, even among the true believers. According to industry accounts, getting clusters up and running can require some significant work. Part of it is that a lot of companies want to reuse the gear that they've decommissioned, and they're finding that it's not on the approved gear list, the approved and certified stuff. Plus, VMware has come out with its own what they call ready node kits, which are cobbles of hardware that they've already put together. They're supposed to be pre-certified, and even those, when you deploy them, sometimes require workarounds or additional drivers in order to work. Users are also complaining about the lack of silicon support, the lack of the ability to support a lot of flash and a lot of additional kinds of memory-based storage products, and the absence of certain enterprise features like deduplication or replication. So there are some architectural criticisms, and we'll probably hear a few from StarWind software, although they complement the VMware installation and make it better from what I can glean. All right, now, what about Microsoft? Microsoft is doing this thing called cluster storage spaces. For its part, its foray into software-defined storage is basically, according to some SDS purists, not really software-defined storage at all. Cluster storage spaces relies on SAS fabrics to deliver, this is groups of SAS disk drives, to deliver data from one node to another. Unlike, say, a StarWind virtual SAN or VMware's now end-of-life VSA, which used Ethernet protocols and iSCSI to share out its data. Now, the dependency on SAS to provide locking mechanisms for logical volumes means that not every storage function has been abstracted away from the hardware. You're still relying on the SAS controller on each drive to do some of the work, and probably a controller inside an array if you get a JBOD or some other kind of array. Now, we'll explore what all of these technology exceptions mean in detail when we do our later webcast that drills down into the Microsoft solution. For now, I just want to repeat some of the things that Microsoft is claiming about its solution. First of all, it says clustered storage spaces leverages technologies that have been around since Windows Server 2012 was released, including clustering services and storage spaces, which are kind of the components of that. Clustered storage spaces can be used to create two basic kinds of storage, if you will. One is clustered storage spaces storage, which is intended to simply provide highly available block storage behind existing implementations of Hyper-V virtual server environments or any of Microsoft's enterprise applications, SQL Server, Exchange Server, and so forth. The other side is scale-out file server, which is actually a cobble of the cluster storage spaces and file server technology that has always been included as part of Microsoft. In fact, here I'm just going to quickly go through these because I feel like I'm using too much time here. But this is a configuration that basically is dedicated just to delivering block storage. It's got a SAS disk drives. They're connected to each node in a cluster, and basically you're able to share that block storage out across all the different workloads that's accessing that particular product. Your other option is the scale-out file server. Scale-out file server, and we'll dwell on these more later on, but it's basically using SMB 3.0. It provides a very scalable NAS-like solution. It's basically front-ending the storage as block storage and then attaching it to a server that's running a file system. So you're basically operating sort of a NAS on steroids with this solution. Now, Microsoft says that this is enabled by a robust functionality set, that it's a laundry list of capabilities and functions that you could previously find only on very expensive proprietary storage arrays, like volumes with different resiliency levels, or thin provisioning of available capacity with forecasting capacity growth requirements, and shareable storage, and caching for read operations, and write-back caching for performance optimization. All these things that you would normally see on a checklist item if you're buying an EMC array or a HDS array or an IBM array. Basically, Microsoft says you can serve up shared block and file storage, leveraging commodity hardware and Windows Server storage spaces and clustering for a fraction of the price of either a NAS appliance or other types of products from EMC or NetApp or a black box array SAN. And that, of course, has both its upsides and its downsides depending on who you ask. In conclusion, I'll just say that a lot of Microsoft marketing, curiously, aims at contrasting its approach to VMware's approach. Despite the latter's effort to make the traditional SAN storage the whipping boy in its own rhetoric around virtual SAN, Microsoft says that NAS and SAN are part of the VMware solution, and that its rival Hypervisor's poor I/O handling requires the need to purchase very expensive storage solutions. So what do you do instead? You deploy Microsoft and its clustered storage spaces, provide great cost savings. The result, in one writer's words, is a virtual storage appliance that can be mounted to any existing server hardware, and any storage that can be mounted to the server. So as a bonus, the platform provides a way to converge and convert and migrate virtual machines formatted to run with VMware hypervisors into a Microsoft Hyper-V environment. That's actually one of the extra value adds here, is that they've positioned their product to help you migrate off of VMware. All right. Plus, the resulting storage avails itself of ongoing storage improvements that Redmond is making to its own SMB 3.0 protocol, including transparent failover, direct and multi-channel operational modes. According to analysts who are engaged by the vendor to estimate the value, they claim that the storage spaces with SMB can deliver nearly the same performance as expensive fiber channel solutions, but at about 50% of the cost. And there are different views of this total cost of ownership, of course, but let's leave that for the deep dive discussion we do later. So anyway, I'm going to quickly jump through these two. There are challenges right now to software-defined storage, both in the virtual SANs that are created by VMware and, of course, on the Microsoft side as well. I'll let you read these slides offline, and there'll be a paper that you'll be sent, those of you who are in attendance today, that will give all of this in great detail. I'm using way too much of our time here, and I want to make sure we get to questions that have good answers. I would also be a little concerned about whether or not the TCO models that are advanced by these vendors are in line with the thinking right now of leading vendors or leading analysts. The analysts are saying that in highly virtualized environment, the need to replicate data behind multiple servers is actually increasing the rates of storage capacity demand to somewhere between 300 and 650% per year, which, if that's true, would negate whatever cost savings you think you're going to glean from going that way. And that's at a time when we're all being required to do more with less and bend the cost curve in storage. So, and then, of course, my biggest concern is we're trying to replace storage-savvy administrators with virtualization administrators who may not know anything about storage. At the end of the day, if you have both, who's going to be responsible for allocating that storage capacity? So those are just questions that are rolling around in my head right now that I think have to go into a decision about the efficacy of this architecture and whether I want to deploy it. Now, I'm going to get some contrarian views from the fellow who we're going to talk to now for about the next, I would say, 10 minutes or so. Max is with our sponsor, StarWind Software. Let me get to his bio here. Max Kolomaitsev is the product manager for StarWind Software. He's been responsible for quality assurance and technical support for the past 7 years at StarWind around their virtual SAN product. He has 10 years of IT experience with expertise in a broad range of areas, including storage, hyper-converged server virtualization, and, of course, virtual desktop infrastructure. And if you've heard his name elsewhere, it was probably in his role as the host of StarWind's excellent technical webinar series. So, hello, Max, and let's get down to our chat, if we could. Are you with us?
I am with you. Hi, John. Hi, everyone. Thank you for attending our today's event. Thanks for inviting me.
My pleasure. Why don't we start out? I have a slide here, but I'm going to let you synopsis it for me. Give us a little bit of background on StarWind so that the folks who are on the call who maybe aren't familiar with your company will have a better idea of where you're coming from.
Right. So StarWind was first released in year 2003, so that was shortly after iSCSI appeared on the market as a concept. At that point, the company we were working at was called Rocket Division Software, and later on in 2009, StarWind spinned off with the venture capital and is now a separate company with more than 30,000 users and more than 200,000 paying customers. And our current customers include Fortune 500 as well as Fortune 100. We're headquartered in Wakefield, Mass, and right now we have a lot of technology partners like Microsoft, VMware, IBM, Dell, and more are coming. So I guess that's
so you're not allowed to say anything bad about Microsoft or VMware. Yeah, my understanding is, though, that you guys invented this whole concept of a virtual SAN. Can you give me a little bit of background on that, just so I'm clear on what the facts are there? Did you invent this technology?
Well, I cannot say that one man invents such kind of technology. I mean, at that point in 2011, I got an idea that our traditional SAN configuration can be a little bit simplified if I do the QA testing by just connecting the storage of the Hyper-V servers in the loopback mode. And at some point it started working, so I came to our R&D and said, okay guys, so now we can utilize twice as much servers and do twice as much testing. And then they scratched their head and said, okay, but that's actually a good selling point. And a few months after that, we released our first hyper-converged storage product, which was called StarWind Native SAN. And at that time, it really exploded the market. I mean, in those days, there was no hyper-converged storage term yet. So that was a unique solution. Some people didn't really understand how it works. They thought it's doing some sort of replication from the cluster level, so they didn't even realize it's doing block level replication in the backend. But I'm trying to get not too technical with the very beginning here. So we're talking about.
Let me bend the question a little bit then. While some vendors are pushing the concept that all of the server-side storage actually devolved from the era of high-performance computing, where they're doing massively clustered systems with their own storage on each system. You guys actually are pretty laser-focused on supporting the needs of smaller firms and firms that don't necessarily have large IT staff or big budgets for storage. Can you kind of tell me, how did you find your way into that the SMB market and the robo market, if you will?
So with us being sort of a pioneer in the hyperconverged market, we started promoting the software for robos and small offices who immediately got a lot of traction, and they want to achieve that high availability with minimal amount of hardware, but they have the budget to get a hardware SAN or a set of hardware SANs for high availability. So at that moment, we were really one company who offered such kind of setup. So there were definitely software-defined competitors to us, which would do classic setup with 2 separate SANs and 2 separate hypervisors. But for all these small companies, they started saving on the hardware by just using our software. And after that, it was more of word of mouth, where little small companies and startuppers just say, okay, you're starting, use StarWind, you'll be able to scale later. This is a very good starting point. And this is how we actually got our target market right now. So, I mean, with the release of Virtual SAN, we also get a lot of more interest from the cloud providers as well as companies doing VDI deployments. But everything started from SMB.
Well, the interesting thing here is that when I do a search on Google for Virtual SAN, these are the diagrams that pop right up to the top when I go to images, and they're diagrams of your product. I mean, against the backdrop of a VMware setting or against the backdrop of a Microsoft setting. I know that the party line over at your company is basically that you are complementary to VMware and to Microsoft. You're not trying to usurp their value case. You're trying to help them. Can you give me? Let me jump forward a little bit. Can you give me a little bit of background on how you complement, say, VMware, the VMware story? Are you competing with them? Are you opening the door for them to do support the smaller customer? How does that work?
Well, with VMware right now, we do have a free version which can provide high availability for 2 vSphere hosts. So it's essentially working like VMware VSA did, but the idea is that we minimize the hardware footprint from 3 hosts just to 2 host installation. And this is the scenario where VMware doesn't work with their Virtual SAN product, and they're not interested in that kind of market. But a lot of people are interested in using vSphere as main hypervisor, so they really want to benefit from high availability. They want less hardware used, and they want all these fancy features VMware Virtual SAN provides. So we released StarWind Virtual SAN free for vSphere to cover that hole in the product line, and now VMware can sell their vSphere licenses to smaller shops who don't have 3 servers yet, and StarWind helps them to converge their storage and get true high availability. And I mean, on top of that, StarWind also allows some additional things like not using a switch for the backend, which is the case with VMware Virtual SAN. So we can use straight 10 gigabit connection between 2 servers, and that will be completely sufficient. And it also doesn't have that strict HCL where people need to choose their servers carefully, and there is really no way to reuse existing hardware, which is obviously not the case with StarWind Virtual SAN.
Okay, so I'm going to summarize this very rapidly. Basically, what you've done is you reduce the hardware complements that are required for the smaller shop that doesn't necessarily want to do a 3-server cluster, and you are also enabling the support for different kinds of storage equipment, different kinds of disk and flash and so forth, but you don't necessarily require the switching infrastructure and that sort of thing that may be useful for a larger company. Let me jump over real quick.
We don't require switching.
Pardon me? Say again?
Yeah, so we don't. Just wanted to say that we don't require the switching. We don't have mandatory flash, and even if there is a bigger vSphere deployment, StarWind doesn't necessarily need to be installed on all the hosts. There can be 2 vSphere hosts feeding the storage to the rest of, let's say, a 10-node cluster. So there's a little more flexibility with StarWind solution, and VMware still sells the license, so we just provide that added value.
Okay, and again, to the audience, we're going to be drilling down into the specifics of the VMware topology and how the StarWind topology complements that in a later webinar. This is just getting the highlights out there. Similarly, with Hyper-V, you've got a similar story. You're providing certain features that they don't provide, and you're doing a couple of other things that facilitate the performance of their solution. Tell me a little bit more about how you're complementary to the Microsoft Hyper-V, just the high points here.
So the high points, first of all, that's the same footprint highlight, which, we're the only company on the market which allows to build a fully fault-tolerant Hyper-V cluster with just 2 physical servers and no additional hardware. And this is where we minimize the hardware footprint of Microsoft installations, and this then has 2 branches. First one is the hyper-converged Hyper-V environments, where people can easily scale from 2 to more servers and gain more storage and computes with no extra unexpected expenditures.
Okay,
and
sure.
Yeah, and one more thing is that StarWind complements the Microsoft's new vision and new strategy of shared storage, which is the scale-out file server and clustered storage spaces. So instead of external SAS JBOD, StarWind can go with hypercapacity SATA and uber-fast PCIe flash cards, which is not the case with the JBOD environment. And at this point, we got more benefits, because even if we use SAS flash, we're still bottlenecked by slow SAS links. And until we get the new hardware and get the new SAS fabric, which is faster than 6 gigs or 12 gigs, we can still use locally attached PCIe flash and still enjoy local I/O without being bottlenecked by that slow fabric.
All right. Well, I'll tell you what, that's a lot of great information. We're getting overloaded here with questions. I feel like we need to jump into a few of these in the last 7 minutes we have available here. I'll also remind everybody that if you have a question, put it in, because there are going to be 2 drawings for trial versions or a license free versions of StarWind Software's Virtual SAN provided at the end of today's session. One of them is going to the person who asked the best question. I love this question. Somebody said, what is VMware? I don't even want to go there. Someone else, though, asked me a question. Many server virtualization projects that they've heard of use NAS as the storage component. What's wrong with that strategy? Why do we need to go to this Virtual SAN idea? Can you respond to that? Why not just use a NetApp filer? Why are we talking about using all this commodity gear and do it yourself?
I mean, there is a saying, there is many ways to skin a cat. So you can do your virtualization project with standard hardware, but their idea is to sell you a unit, then support it for 3 years, and then once you need support for 3 more years, that's going to cost you like 2 additional units. And instead, the idea of software-defined storage is to get a commodity server, install the software, be able to get all the new fancy features, be able to get new hardware with no dramatical TCO increase. And let's say if you want new servers, you just reuse your existing StarWind license on the new servers. And you have predictable support contract figures, and you can easily scale or do a forklift upgrade with zero downtime. So this is something which hardware vendors don't offer anymore, and that's why you see more and more vendors trying to go into the software-defined niche or looking to buy smaller software-defined storage vendors, because they see that just doing the hardware is not working anymore. It has to be closer to the hypervisor, closer to the applications to get that performance, to get that level of resilience, and to minimize the number of servers you're actually managing and buying.
Another question that came in is, I'm not a storage expert, but it seems like we're getting better at configuring low-cost storage and making it simpler to deploy. Do we have enough automation in storage management that my lack of skills won't hurt me the first time that a drive fails? Is there anything about StarWind Virtual SAN that monitors the status of the underlying infrastructure, the underlying plumbing and hardware that's involved, or do we still have to go to some lengths, either through the operating system or the hypervisor, in order to identify a burgeoning problem or a piece of equipment that's failed?
Actually not. So there is definitely some equipment which is vendor-specific, and there will be vendor-specific events for certain equipment failures. But if something happens to the storage, first of all, you've got high availability, so that does not disrupt your operations. And secondly, you immediately get alerts sent to your email or just forwarded to your event log, and you can then collect the event log from the operating system. So that is all configurable on the OS level. And again, Microsoft provides really great functionality for forwarding the events and notifying administrator about something happening to the server. So we sit on top of that, and we provide some additional information which is vital to the storage administrator who is working with that storage.
Okay, and then another question that came in is, with the rise of software-defined storage, is that the reason why all the brand-name vendors are seem to be having hard times selling their gear? That's a good question, actually. Do you see software-defined storage the reason why a lot of the major brand-name vendors are down year over year on the sale of their SANs or the sale of their complex storage rigs?
Yeah, so software-defined storage is one of the reasons. I mean, the storage admins are getting smarter. So big companies still try to buy the pre-configured hardware storage, but more and more companies are going software-defined, and that's why vendors start going software-defined. I mean, look at Microsoft, look at VMware. They now all offer the software-defined storage models. And I'm not sure Microsoft is going down that route, but VMware actually unifies with some hardware vendors to provide a pre-configured hardware piece for the software-defined storage installation. So there is no way hardware can be sold all the time. I mean, there are certain scenarios where it can fit, but more and more people realize that there is no one-size-fits-all, and you cannot buy a 40-unit array for just your domain controller and stuff like that. So it has to be smarter.
I'm going to display for this last question the resource list that you guys put together where people can go for more information. There will also be a white paper covering this session today that will be sent out to everyone who attended via email, and then will be available for download on folks who replay this event later on. That will be available probably by the end of the week. But I wanted to ask one last question before we turn things back over to Chris, and I thought this was an important one. Somebody got a little confused, and they said, are you strictly for small companies and small implementations, or can your virtual SAN scale? What are the limits of your scaling?
Okay, so the limits of our scalability, so what we've tested in our lab was 36 nodes. That is the scalability we've got with StarWind Virtual SAN and all-flash configuration. That was something I personally tested, and theoretical scalability is beyond 64 nodes. So there will be another event where I can get into the scalability part in more detail. So the idea is that StarWind maintains high availability in clusters of 2 or 3 servers, and then these can be cross-mirrored. So essentially, if you're building a large environment, you're just doing it using multiple building blocks. So it's easier for you. You still get local I/O, but you can scale infinitely.
Very good. Okay, well, that's a lot of information to absorb in one sitting. Believe me, the information quantity is going to get even more dense. We do our drill downs into VMware and into the Hyper-V and clustered storage spaces solutions in future webinars on this topic over the next few weeks. I'd like to thank you very much, Max, for fielding all these questions. I know that I think where you are, it's probably the middle of the night right now. And on behalf of StarWind Software and myself, Jon Toigo, I'd like to thank everybody for coming to today's session. And now I'm going to hand things over to Chris. I think he's got some exciting news about a drawing or two for a free copy of this Virtual SAN software. Thanks again.
Yeah, guys, thank you so much, Jon and Max, both for presenting today. Yeah, so as Jon mentioned, 2 lucky random winners are going to get a free copy of StarWind's Virtual SAN. And I would like to announce that the 2 winners are Gerald Kruger. If I pronounced your name wrong, Gerald, I apologize. And the other one is Bruce Perrin. Thank you both for being on throughout the entire webcast today and also asking phenomenal questions for the Q&A. If you didn't get your questions asked in the Q&A, don't worry. We'll have somebody from StarWind Software get in touch with you guys after the presentation is over. We'll supply them with your name and email address so they can get your question answered. But a big thank you to everybody for joining us for today's webcast, sponsored by StarWind Software and brought to you by Virtualization Review and virtualizationreview.com. Thank you all for attending today's webcast, and we hope to talk to you again soon. Thank you, everybody. Have a great day.
This concludes today's presentation. Thank you for your participation.